Hello students, so far we have studied about addition, subtraction and multiplication of integers, and we have studied that closure and commutative property is followed in case of addition of integers. But does multiplication also follow these properties? So today we are going to discuss about the properties of integers under multiplication. Well, let's first discuss about the closure property of integers under multiplication. So, just recall what we have studied about the closure property of integers under addition. Well, it states that on adding two integers, their sum will always be an integer. For example, 5 plus 3 is equal to 8 and minus 3 plus minus 3 is equal to minus 6. Similar is the case with closure property of integers under multiplication, which states that when we multiply two integers, their product will always be an integer. For example, if we take the case of 5 multiplied by minus 5, then it comes out to be minus 25, which is also an integer. And if we take the case of minus 5 multiplied by minus 5, then it comes out to be 25, which is also an integer. Thus, by these examples, it is proved that multiplication always follows the property of closure for integers. Next, we will discuss about the commutative property of integers under multiplication. So, again recall what we have studied about this property of integers under addition. Yes, it states that when two numbers are added, their sum is same regardless of the order in which they are added. That is, A plus B is equal to B plus A. You can add two numbers in any order. Similar is the case with multiplication also, where commutative property states that even if we change the order of integers in the multiplication expression, the result remains the same. That is, A multiplied by B is equal to B multiplied by A. Let's understand this by taking a few examples, such as 6 multiplied by minus 2 is equal to minus 12 and minus 2 multiplied by 6 is equal to minus 12. So, in both the cases, we get the same result, that is minus 12. And similarly, minus 4 multiplied by minus 2 is equal to minus 2 multiplied by minus 4, which comes out to be 8. As we have studied that product of integers of similar signs is always a positive integer. You can multiply two integers in any order. Next is multiplicative identity property of integers. Whenever a number is multiplied by the number 1, then it will give the integer itself as the product. Therefore, the integer 1 is called the multiplicative identity of that integer. Next is associative property of multiplication of integers. As we have seen this property in case of addition, that if we have this equation 5 plus 7 plus 3, then it comes out to be 12 plus 3, which is equal to 15. And if we see the second case, then 5 plus 7 plus 3 is equal to 5 plus 10, which is equal to 15. So in both the cases, we are getting the same result. Therefore, 5 plus 7 plus 3 is equal to 5 plus 7 plus 3. The associative property of addition tells us that how we group the numbers does not alter the result of the addition. Similarly, on multiplying more than two integers, the product does not change even if the grouping is changed. That is, A multiplied by B multiplied by C is equal to A multiplied by B multiplied by C. So, if we have three numbers, let's say 2, 3 and 4, and if we have to determine the product of these three numbers, Then how do we calculate it? Well, we can represent in the form of an equation where we can write 2 multiplied by 3 inside a bracket and 4 outside the bracket. Now, we first calculate the product of the numbers inside the brackets. So, 2 multiplied by 3 is equal to 6 and 6 multiplied by 4 is 24. Now, if we group the numbers in other way, like if we place 2 outside the bracket and 3 multiplied by 4 inside the bracket, then again we first calculate the product of the numbers inside the brackets. So, 3 multiplied by 4 is equal to 12 and 2 multiplied by 12 is equal to 24. Thus, you can observe that in both the cases, we are getting 24 as an answer. So what do you infer from this example? We have inferred that it does not matter whether we multiply 2 and 3 first or 3 and 4 first. The result which we are going to get remains the same. Thus, we can say that multiplication follows the associative property of integers, where associative property of multiplication states that when performing a multiplication problem with more than 2 numbers, it does not matter which numbers you multiply first. Next, we will discuss about the distributive property of multiplication. Well, what do you understand by the name itself? Distribution means to give a share to each number of recipients. So, in mathematical terms, this distributive property states that when a number is multiplied by the sum of 2 numbers, then the first number can be distributed to both of those numbers and multiplied by each of them separately. And on adding the 2 products together gives us the same result as doing each multiplication separately. It can be represented in this form, that is, A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. Now, let us apply the distributive property and solve this equation. 3 multiplied by 2 plus 4. Here, 3 can be distributed across the 2 plus 4 into 3 multiplied by 2 and 3 multiplied by 4, which comes out to be 6 plus 12, that is equal to 18. Now, we solve it the normal way without using the distributive property. And we first add the numbers inside the bracket, which comes out to be 6. Now, on multiplying 3 gives us the same result, that is 18. Thus, 3 multiplied by 2 plus 4 is same as 3 multiplied by 2 plus 3 multiplied by 4. So, this is the distributive property of integers under multiplication. With this, I end this module and we will meet again with another interesting topic of mathematics.